All right, we're going to go ahead and go over quadratic forms. First thing we're going to do is find factors of 5 and 12 that add up to 23. So the factors of 5 are 1 and 5. Factors of 12, we've got 1 and 12. I'm just going to list them down here, 2 and 6, and then 3 and 4. So we want to figure out which pair to match up with 1 and 5 so that they add up, because this is a plus sign, add up to 23. So let's say we try 3 and 4. Oops. 3 and 4. Well, I could match up this 1 with the 4 and get 4, and then the 5 with the 3, and I get 15. That doesn't quite work. So I'm going to try pairing them differently. So I'll try 1 and 4. 1 times 4 is 20, and then 1 and 3 gives me 3. Notice that adds up to 23, which is exactly what I wanted. Okay, so we figured out the pairing. So I'm going to go ahead and write my answers. We'd have 5. 1 and 5 would be our first term. Now, since it's x to the 4th, we're going to do x squared. And then the 5 was paired with the 4, so they need to be in opposite parentheses. The 4 needs to be over here, and the 1 was paired with 3, so it's going to be over here. The last thing we need to remember is, since this was a positive 12 at the end, that means our signs need to be the same. So this middle sign tells us they both need to be negative. Okay? At this point, anytime you do a quadratic form problem, you need to make sure that you've factored everything completely down. So anytime you still see an exponent, double check to make sure it's factored all the way over the integers. So 5x squared minus 3, we can't factor more because 5 is not a perfect square, 3 isn't a perfect square, and so on. But x squared minus 4, 4 is a perfect square, and it's a difference of perfect square, meaning we're subtracting. So this one actually does factor down more. So we'd still have 5x squared minus 3. It stays the same. But x squared minus 4 would factor down to x minus 2, x plus 2. Let me just go ahead and do one other problem. That's our answer. Now, I failed to mention this on the previous problem. However, the only way you know you can do this method is if your highest exponent is twice as big as the middle exponent. You have 3 terms. Okay? So notice this one, we have 8. 8 is twice as big as 4. So I can go ahead and proceed and do this problem. Well, on this problem, factors of 3 are 1 and 3. Oops, 1 and 3. Factors of 2 are 2 and 1. Those are the only factors. So we need factors of 3 and 2 that subtract to give us positive 1. So we're going to go ahead and combine them. So I might pair 1 with 2 and 3 with 1. If this doesn't work, then I will go ahead and try it another pairing. Well, 3 and 1 gives me 3. 2 and 1 gives me 2. Well, if you take 3, subtract 2, you get 1. So I found the correct pairing. So I'm going to go ahead and put my answer down. So since we had 3 and 1 as our first number, we're going to have 3x to the 4th and a 1x to the 4th, or just x to the 4th. For 2, we're going to have the 3 paired with the 1, so they need to be in opposite grouping. So that's going to be the 1, and the 2 is also, or sorry, the 1 is with the 2, so those also need to be opposite. 2. There we go. Now, the signs, because of this minus sign, we're subtracting, the signs will be different. This tells us that the larger number should be positive, or not the larger number, let me say that again, the larger pairing. So when we paired 3 and 1, that was bigger, 3 times 1 is 3, than 2 times 1. So the larger number, or the larger pairing, excuse me, is 3 and 1, so that's positive, and this is negative. Once again, we need to check to see if these factor down more. So this is to the 4th power, this is also to the 4th power. If it's to the 4th power and there are 2 terms, it could be a difference of perfect squares again. However, 3 and 2 are not perfect squares. Now on this one, 1 is a perfect square, however, it's not a difference with adding. So we are done factoring.